In this lesson, we are going to discuss the chain rule. So the chain rule is used when you differentiate a composition function. So what is a composition function? Simply speaking, composition works like a Christmas gift. So let's say you have a gift, and then this gift is wrapped by multiple boxes. So you have one box, another box, and then one more box. So it's wrapped by 3 boxes. How do you get the gift? So you have to open the first box, and then the second box, and then after you open the third box, you can take your gift out. So this gift again is wrapped by 3 boxes. To go to the gift, you have to go through the box one by one from outside to inside, right? So what is a composition function? So let's say we have a function like this. So f of x is equals to e to the x squared plus 5x. And then we have to differentiate this function. So e to the anything is always e to the anything, right? So e to the x squared plus 5x. So for chain rule, since we have a parabola inside an exponential, so we also need to take the derivative of this parabola. So overall, we have e x squared plus 5x. The derivative of that is 2x plus 5. All right. So that is how we do the chain rule. So let me give you a general formula. So let's say we have a composition function. We have a function f. So that is f of g. So f of g is a composition function. That means f of g of x. We have one function inside another function. So when you differentiate function capital F, so first you have to differentiate function f first. I call that the inner function, the outer function and the inner functions. So f is outer, so g of x, and then you multiply the derivative of g of x is from outside to inside. I call that the outer function and the inner function. So back to our very first composition function, the exponential, I call that the outer piece. The x squared plus 5x, I call that the inner piece. So we go from outside to inside, just like you open up a box of your Christmas gift. So you open up the outer box first, and then the second box, and then the third box, and then you will reach to your gift. All right, so that's how the chain rule works. And then other than chain rule, so if we go back to the top of the video, so we have a list of differentiation formulas. Here are all the formulas we have discussed so far. So using all of this formula, we are going to differentiate all of this function using chain rule. So let's start. So A, we have y equals to x squared times e to the negative 3x, right? So this function, we have to differentiate that. So what this is a product, right? So that is y is equals to x squared times e to the negative 3x. So that one definitely has a chain rule, definitely has a product rule in it. Speaking of product rule, f times g of derivative. What is the derivative? So that is fg prime plus gf prime, right? So this one y prime is equals to fg prime, so x squared, and then this has a chain rule. So chain rule, let's do the chain rule in a slow motion. E to the anything is always e to the anything. Since negative 3x is inside an exponential function, we need to take the derivative of the negative 3x. I'm not going to do that right now, so I'm going to just prepare the derivative because I would like you to get used to the chain rule. And then plus gf, so g is e to the negative 3x, and then f prime is the derivative of x squared. That equals to 2x, and then we take care of that derivative. So y prime that equals to negative 3, right? So we have negative 3 x squared e to the negative 3x, and then plus 2x e to the negative 3x. So this one is the derivative. Or if you want to put it in a factor form, that's okay. You factor the e and the e to the negative 3x out. So you have negative 3x plus 2 inside the parenthesis. Not too hard, right? It's a chain rule. Just take one more step. Again, we go from outer piece to the inner piece. So B, we have f of x equals to 2x minus 4 to the 4th power. And then x squared plus x plus 1 raised to the 5th power. All right, so this one definitely has a chain rule in it, right? And then this one has another chain rule in it. So since the overall function is one product times another product, we will have to use the product rule again, which is fg prime plus gf prime. So we have a chain rule inside a product rule. So let's start f prime of x. So fg prime, we copy the f, 2x minus 4 to the 4th power. Another way to use the chain rule is the 2x minus 4 raised to the 4th. You don't want to open up the 4th power, right? Because that is a lot of algebra in there. And then g prime, so this is your g. There is a chain rule in there. So what is this composition function? We have a parabola, a x square, inside a 5th power. So the outer piece is the 5th power. The inner piece is the parabola. So we bring the 5th power down. 5th power, and then whatever that is, I don't care at that point, and then we take 5 minus 1. Now, what is the inner piece? The inner piece is x squared plus x plus 1. Are we done? No, we are not. We haven't taken the derivative of parabola yet. So the derivative, I will just prepare the derivative and not do the derivative at this point. Plus 1. So that is fg prime. And then we plus gf prime, right? So g, we just copy the g, x squared plus x plus 1 to the 5th. And then f prime is right here. So we have to take the derivative of that. So we bring the 4 down, whatever the inner piece is, I don't care right now. 4 minus 1 is 3. So which one is in which one? So we have a linear function, 2x minus 4 inside a 4th power, right? So the inner piece, now we fill it in, minus 4. And then, since we have a linear function inside, we take the derivative of that as well. We just write the derivative out and not do the derivative at this point. With more and more practice, you can just do the derivative. So you don't need to prepare an extra line. But since we just discussed the second problem, it is good to show all the work. So now let's bring all the pieces together. So we copy that, 2x minus 4 to the 4th, and then 5 times x squared plus x plus 1 to the 4th. The derivative of that is 2x plus 1, and then we plus x squared plus x plus 1 to the 5th, and then the derivative of that is just equals to 2, right? And then the 2 times 4, you have 8 times 2x minus 4 raised to the 3rd. And then you can just put, you can simplify as much as possible. So we have 5 times 2x minus 4 to the 5th, and then times x squared plus x plus 1 to the 4th, and then plus 8 times 2x minus 4 to the 3rd, and then x squared plus x plus 1 to the 5th. To me, I will just take that as a final answer. If your instructor would like you to put this in a factor form, then you can do a factor form. So this one, the highest power, the smallest power is 3. This one, the smallest power is 4, right? So I can bring a 2x minus 4 to the 3rd out, and then x squared plus x plus 1 to the 4th out. And then what do we have inside the square bracket? We have 5. So now the 2x minus 4, we only have one of this left. Oh, how come there is a circle? And then we have 8, and then x squared plus x plus 1. That's it. So this is the factor form of your answer. All right. So moving on to part C. Part C, we have a quotient rule. So in C, we have y equals to the square root of x divided by x plus 1. Square root is the same thing as 1/2 power. So we have a 1/2, and then y prime. So y prime, we have a rational function inside a square root function. So the outer piece is the square root, right? So you bring the 1/2 down, whatever inside, I don't really care right now. 1/2 minus 1 is negative 1/2. And then you fill in the blank. X divided by x plus 1. And then you take the derivative of the inner piece, which is x divided by x plus 1. That requires a quotient rule. Quotient rule is gf prime minus fg prime. I will keep reminding you this, so when you do your homework, you don't need to go back to your formula sheet anymore. So y prime, that is equals to 1/2. In my perspective, I accept, in my class, I accept negative exponent. So I will just leave the negative exponent right there. And then this one is a chain rule, so we have x plus 1 square, and then the top we have g f prime, so x plus 1, the derivative of x is 1, and then f is x, the derivative of g is 1. So overall, we have y prime equals to 1/2, and then x divided by x plus 1 to a negative 1/2, and then this is x plus 1 minus x, right? So we have 1 divided by x plus 1 square. So this is my final answer. All right, doing good, right? So let's move on to part D. So part D, we have y equals to e to the tangent theta. Okay, so we have a tangent inside an exponential. So y prime is the e to the anything, is just e to the anything. However, the tangent is a function, right? So you also need to take the derivative of tangent theta. So the derivative of tangent is secant square. So you have e tangent theta times secant square theta. So that is your final answer. In case you are wondering, hey, I have y equals to e to the x. Can I do chain rule? Yes, you can do chain rule. So this one, we have an x inside an exponential. So y prime e to the anything is just e to the that thing, right? And then you take the derivative of x. What's the derivative of x? Which is 1. So overall, you only have e to the x. That's how you do it. And then moving on to e, let's switch e to a different color. So e, we have f of t. Haha, this one, I like this one. E 2 raised to the t, and then raised to the third power. So one formula that I want to remind you, you don't use that very often. So it's the derivative of b to the x. So that is equals to b to the x times ln b. However, if x is a function, not just x is something more complicated, you also need to take the derivative of x. So since the derivative of x is 1, then that is b to the x times ln b, right? So this is the formula that we discussed before. So this one f prime of t, that is equal to what? You copy what you saw. So 2t to the third, and then times ln the base, which is base 2, right? And then what else? You also need to take the derivative of the exponent, because you have t to the third power inside an exponential. So it was supposed to be 2 to the x, right? So we have an exponential function, 2 to the t. We have a t to the third power, but we have this third power inside the t. So we have a third power inside an exponential function. So when you take the derivative of the exponent, that generates a 3t squared. So overall, you have 2t raised to the third times ln 2, and then you multiply 3t squared. That's your answer. Moving on to a more complicated exponential function. So part f, we have y equals to 2 raised to the third power, raised to the fourth power, and then raised to the x power. All right, so y prime, we have 2 to the anything, so 2 to the third to the fourth to the x, and then ln the base, and then what else? And then you multiply the exponent of 2, whatever the exponent is, you bring everything in there, which is 3 raised to the fourth raised to the x. So you have another chain right there. So this is a 2, 3, 4x ln 2, and then you multiply, you have 3 to the fourth to the x times ln 3, and then you take the derivative of 4 to the x, because you are using a chain rule. And then the 4 to the x, what do you have for 4 to the x? You have 4 to the x times ln4, and then the derivative of x, right? So the derivative of x by chain rule. So since the derivative of x is equals to 1, you can disregard this. We got that, and then you copy everything down. All right, so this one you have ln2 times ln3 times 2 to the 3 to the 4 to the x times 3 to the 4 to the x. And then overall, if you want to organize this one more time, you have ln2 times ln3 times ln4, and then times 2, 3, 4x, 3, 4x, and then 4x. That is your final answer. All right, moving on to part G. So part G is another chain rule. So let's change color again. So part G, you have y equals to cosine 1 minus e to the 2x divided by 1 plus e to the 2x. So this one you have a rational function inside a cosine, right? So the derivative of cosine is negative sign. So negative sign of this thing. I don't care what it is. And then you multiply the derivative of that thing, which is 1 minus e to the 2x divided by 1 plus e to the 2x. Of course, you have to fill in the blank. Okay, we have to do a quotient rule. Remember quotient rule? We have g f prime minus f g prime divided by g squared. So y prime, we copy this one more time. And then the quotient rule, we have to prepare a long fraction bar, square the denominator, and then g, so that is 1 plus e to the 2x, and then the derivative of the top, the derivative of 1 is equals to 0, and then e to the anything is just e to the anything, right? What else? You also need to take the derivative of 2x, which is equals to 2. So we just did a chain rule, and then minus for the quotient rule, and then function f, which is the top, and then derivative of the bottom. The derivative of 1 is 0 plus e to the anything. The derivative of 2x is 2. And then just clean up the top. Y prime is negative sign of 1 minus e to the 2x divided by 1 plus e to the 2x. And then we clean up the top. The top we have negative 2 e to the 2x, and then minus 2 e to the 2x times e to the 2x. So e to the 2x times e to the 2x, that is a 2x plus 2x, you get a 4x. So e to the 4x, and then minus, so that will be 2 e to the 2x, and then minus you have a plus 2 e to the 4x. So you can definitely do some cancellation, forgot the square, 1 plus e to the 2x square. So this one, how do you do some simplification? The 4x is gone, right? So this one and that one, they got cancelled, and then the rest you have a negative 2 minus 2, you have a negative 4. So y prime is equals to negative sign 1 minus e to the 2x divided by 1 plus e to the 2x, and then you have negative 4 e to the 2x divided by 1 plus e to the 2x, and then square. So this is your final answer. Doing good. So let's move on to part H then. Part H, we have 3 layers. So part G, this is part H, we have 3 layers. F of t, that is equals to tangent of secant of cosine t. So you have 3 layers. We have a cosine inside a secant, and then you have both inside a tangent. So you have to do the chain rule 2 times. So f prime of t. So first, the derivative of tangent, I am only treating that as tangent of something. The derivative of tangent is secant square of everything inside the parenthesis. And then you take the derivative of everything inside the parenthesis, which is secant of cosine. And then you fill in the blank. All right, so we are one step closer. So next you have to take the derivative of secant. The derivative of secant is secant times tangent, which is secant of the stuff inside its parenthesis times tangent of its stuff inside the parenthesis. That stuff is cosine. Are we done? No, we still have a cosine in those two trig functions. So we also need to take the derivative of cosine. So this is our second chain rule, right? So 2 times cosine t, and then don't forget that we have to copy everything else. Cosine t. All right, so the derivative of cosine is negative sine t, right? Sine t. And then you can put everything together. So let's put the negative way up front, this negative. So let's put that way up front, f prime of t. So that is negative secant square, and then secant of cosine, and then secant of cosine t times tangent cosine t, and then times sine t. So that is your final answer. Moving on to the last part. So moving on to part I. So part I, we also have a pretty complicated function. So part I, we have f of t equals to sine square of e raised to the sine square t. Okay, one property that you have to know is, so let's draw a line to divide them. So one thing that you have to know is the sine square of x, that is equals to the square of sine x, just 2 different locations to put the square. All right, so this one is f prime of t. So that, let's draw a square bracket so we can put the square outside. So you have sine of e of sine square t. So the first step is you bring the 2 down, these 2. So you bring it down. I haven't started the derivative yet. So this is my first line of my derivative. So 2 to the that piece, and then this is first power, and then you take the derivative of everything inside the square bracket. So this is a sine e sine square. So this is the derivative of sine e to the sine square t, and then this derivative applies to the sine, right? So the derivative of sine is cosine. You have e sine square t, and then you take the derivative of that, the stuff inside the cosine parenthesis, which is e to the sine square t. And then the derivative of that is e to the anything, right? Sine square t, and then do what? And then you have to take the derivative of this sine square t. The derivative of sine square t, allow me to do this in one step, otherwise this paper is not long enough to fit the whole line. So first you bring the square down, so 2 sine t, right? And then you also, here, t square, you bring the 2 down, right? So this becomes a 1. The derivative of sine is cosine, so you have a sine t times a cosine t. So that is the result of this. So let's bring everything down. So overall, you have 2 times. Actually, let's don't put it in this way. Let's don't put it in this way. Let's put it in this way. You have sine square of e sine square t. Okay, so that is one piece. And then we have a cosine e sine square t. That is this piece. And then you bring this down here, and then you multiply e sine square t, and then you have 2 sine t cosine t. So this is the final answer. So that will be all in this part. In the next part, I will discuss the first and second derivative using chain rule. All right, I see you there.